Thank you for having me. As you mentioned in your video just a moment ago, we are used to coming to these sessions face to face. So it is an interesting world that we're in at the moment. But hey, let's give this a go. And hopefully we have tested everything. So hopefully everything will work as expected today. So what am I going to be talking about today? Well, we are going to be talking about threat modeling, and I'm going to introduce you to a system called CAIRIS that we use for, as it says here, towards usable and secure requirements engineering. So just to give a little bit about us. So on the left, we have Dr. Shamal Faley, and that is me. I'm on the right, Duncan. So again, I'm very pleased to meet you all. So let's get cracking and talk a little bit about CAIRIS and a little bit about what we do and where we're from. So we are actually part of the Bournemouth University Cybersecurity Research Group. We do a lot of things there. So it's not just myself and Shamal. There's many of us. We cover many topics: security, risk, privacy, and so on. So really, that's where I'm going to start today, from a security and a risk point of view. But I'm actually going to start with a little bit of the science, because we are researchers after all at heart. So let's start with bounded rationality. If you haven't heard of this term before, let me just take a step back and make this sound a little bit more simple. Because this example, it could apply to you crossing the road, so risk assessments, or it could apply in a design context as well. So really, when we come to making decisions, it is about having suitable information to help us make those decisions. And sometimes that is a real problem. So certainly with a risk assessment, you can only ever assess risk based on what you know. Sometimes as well, decisions need to be made quickly. So with a limitation on information, and we have to make a decision based on what we know. Sometimes, as we're saying here, some of these decisions are suboptimal. Certainly from a psychological point of view, to help us make these decisions, we do have, well, what we have called here cognitive limitations, but we also have this, this feeling, so the affect, if you like. And it's how we feel can affect how we can make decisions. So there's lots of things that we need to consider here. But we come to this thing in the middle called bounded rationality, because what we are trying to achieve is obviously the best option, the best decisions based on the information that we know. But sometimes because of bounded rationality, we are limited to our decisions that we can make. So we're never really going to reach that optimal performance, and therefore we're not really satisfying the goal. And so that's why we use the word satisficing. So satisfice is it's a compromise. It's good enough. It'll do, but it's not really fully satisfying the goal. So this, from a science point of view, is a real problem. Certainly, as I mentioned, when it comes to risk assessment, or even in a design context, making sure that we are threat modeling things to our best of our abilities. What we also have is another problem as well, because as is often the case, security is seemingly becomes the responsibility of the developers, the coders. But that's not fair, surely, because surely security is everybody's problem. Certainly in the design context, many of us should have different roles, and therefore we should be thinking about security in different ways. So when it comes to design, we do need this sense of assurance. Certainly if we are looking to have good governance, either from a design team point of view, or indeed the people that are paying for the a particular application to be designed. They are going to need this assurance, and indeed that it's going to work as expected and provide some kind of return on investment. But when it comes to design and engineering, what we must not do is sacrifice agility. And of course, agility, or agile is the word that it links to. It's just an easy way of saying, let's keep everything flexible. So rather than the rigid waterfall approach, we have this flexible approach. But certainly with agile approaches, collaboration is absolutely key. So this could be collaboration between different stakeholders between the operational world and engineering, but certainly good collaboration with people within the design world as well. And this comes back to the point where we shouldn't necessarily be putting security, or at least the responsibility of security, on developers. It's all of our jobs. So we need to be thinking about this a little bit more in our designs, certainly when it comes to security and threat modeling. So to address this, we use CAIRIS. So CAIRIS is an open source platform for building security and usability into your software. CAIRIS also stands for Computer Aided Integrated Requirements for Information Security. So the screenshot that I have here is actually from the website. So do go and have a look at CAIRIS.org for some more information. The quick start button over on the left, if you were to click that, that will actually take you to another page, which is an instruction manual of how to use CAIRIS, if you like. The live demo is something that I'll take you through in just a moment. And the GitHub page will take you here. Because it's open source, you can download it for free. You can download it and install it and use it yourself in your own projects. So if you were to follow that link, for example, which actually is the quick start link, it will take you to pages and pages of documentation that details how the system can be installed, how it works, how you can link things together. It can actually be installed in different ways. So you can actually install it as a cloud platform, if you like. I personally use it for various different things. So it's actually easier for me. On my laptop, I have a virtual machine. So I run a Linux operating system inside my VM. So it's just as easy for me to load CAIRIS onto the VM, and then off I go. And then, of course, I can run CAIRIS either in my browser, in the VM, or outside in my Windows world, which is great. So it's actually very easy to install. And also, if APIs is something that interests you, certainly from an interoperability point of view, because I should stress that CAIRIS is quite interoperable and actually can be used and integrated into other things. So let me just move on to the next slide. I'm noticing that there are things popping up in the chat, so that's great. I'm not looking at the chat at the moment, just as a caveat, only because it kind of blocks my screen. So I will come back to the chat in just a moment. But just a little bit more on APIs. We also have the API hosted on Swagger Hub. So as I say, if APIs is your thing, do go have a look on there on Swagger Hub. For a little bit more information and see how you could integrate it with your systems. Also, we have lots of video tutorials on how to use CAIRIS. These are fairly new. They've come over the last year, but do have a look at those as well. They are useful to help you understand how you can use it, because there is a lot of things in CAIRIS that you can use for different purposes. And I'll explain some of those as we go. So just to give you a very short history about CAIRIS, CAIRIS has actually been around now for just over 10 years. It was first presented at the Requirements Engineering Conference in 2009, and it has undergone a few iterations since then. When it was first built, it was built as a desktop application and did include a number of concepts. However, since then, more concepts have been added, but what was most important is where we've then joined the web app world, if you like, and this CAIRIS became a web app. So about a year ago, the interface had its another update, another overhaul, giving it the brand new interface as we see today, or as I shall show shortly. Also with CAIRIS, if you want to save your models, we can export these as XML files, and these can easily be imported back into CAIRIS at a later date, or indeed shared with other stakeholders. Also, when you export the XML file, if you are the type of person that likes manipulating code or changing things in text, you can actually update your model here and then re-import it later on as well. So it's quite another useful tool, certainly for interoperability. And another tool that we have in CAIRIS is the ability to generate documentation. Now, I will say that it depends on what you're using CAIRIS for, and therefore how you can benefit from this documentation. For example, if you haven't used the requirements elements to add Vulnerability compliant requirements into CAIRIS, then of course it is not going to generate those. But there are other things that it could still generate, and these can be easily copied into your report, whether that's your weekly report, your Scrum report, your annual board report. There are many reports that a lot of this can be useful for. So let's talk about how it can be useful, or some of the things that we have inside of CAIRIS. So really, CAIRIS is based on environments. Some other modeling approaches might use boundaries, but we use environments. So as it says here, environments are contexts context that the system operates in. So just to give you an example there, we could have an environment which could represent a context in an organization or for a system in the daytime, or another context for the nighttime. In some of my work, I use the environments to represent different system views or different perspectives. So let's say if we have 3 systems or 3 organizations, but they all work together in some capacity, each might only have a limited view of each of their interactions. But then by using these different environments, what we can do is get a view of the bigger picture, if you like, which is very helpful, certainly from a risk point of view, because certain risks might only be captured in certain environments. But then once we have a bigger view of these risks and how they might interact with each other and therefore create other risks, this is obviously useful. So there are a number of key concepts within environments. Actually, this slide title works both ways, the key concepts of CAIRIS for environments and the key concepts of environments. As you can see, would be things like tasks, goals, personas, assets, and so on. So I'm actually going to talk about a few of those now, just to help add a little bit more context before I jump into the demo. So assets, let's say from a risk point of view, from a security point of view, is something that we value. Assets could therefore be information. They could also be people, software, hardware. We could generalize and call an asset, or rather a system, we can call that an asset. But systems can also be used to represent organizations or a group, or indeed we also have an asset representative of a system of systems, if that is something that features in your work. So we have these different assets, and assets can be given different values for different things. So for example, an asset might have, certainly an information asset, might have a need for confidentiality, integrity, availability, or even accountability. Certainly from a privacy point of view, there are also privacy properties that we can capture in CAIRIS. And those are going to be important later on, certainly when we get to threat modeling and assessing risk. So we can determine then the impact on, let's say, some information and whether or not confidentiality is breached. This is naturally important for some kind of data protection impact assessment, which we can also do in CAIRIS. So the use of personas. We have assets that are used by people in tasks that they perform. So we represent people as personas in CAIRIS. We also have roles. They are slightly different though. So the role is something which is a little bit more fixed, that somebody does, something that's a little bit more defined. But people are less defined. People are different. Certainly when we think of diversity, we might be doing things in different ways. And even how a piece of software might work in one country or one organization might be different to another scenario. So personas are actually useful for capturing some of these contexts of use. But what I will say is that personas are not like marketing personas, where they are completely made up and therefore stereotypes. Personas that we use here in design and certainly security are very much based on real people, real interviews, or real secondary data. And therefore, they become archetypical users rather than stereotypical users. There are a number of ways that you can create personas, which I won't go into today because that's a whole other session on its own. But for me, I personally prefer to use interviews to gather information for personas. And usually, so let's say, for example, if I was doing some interviews in a call center, maybe I'm interviewing a whole load of customer service advisors, or indeed we could be looking at different roles throughout the organization. Let's just stick with the customer service advisors for a moment. So if I was interviewing, let's say, 3 customer service advisors, that would give me enough information to crunch down and hopefully create a persona or a persona template, as we can see here in the slide. So we would actually use pictures, not of the real people. We would probably go online and source some images that can be used with Creative Commons licenses. But we use these to really personalize the personas, to make it a little bit more real, if you like. And then we'll be able to, from our analysis, we'll be able to understand what their potential activities are, attitudes, aptitudes, motivations, and skills. So all of this, again, is really very useful when we're trying to determine elements of security and risk. and therefore how we can reduce it. Because understanding that the people interaction is so important. And strangely, it's the one thing that seems to get forgotten, certainly when we come to security. This is why I can't stress enough that these are archetypes, not stereotypes. Because if you start analyzing security aspects from a stereotypical point of view, you're really not capturing the correct context of use. So this is why personas are really, really important. Certainly when we're understanding their activities, or tasks, as we call them in CAIRIS. So with the activities that they perform, we can relate an asset to these tasks within CAIRIS. And then once we have a combination of a number of tasks related to a number of assets that may be used by a particular persona or personas that could be associated with roles, this actually now starts to help us build this picture. We can also include use cases as well. Although I'm not really discussing use cases here, they can be associated with tasks in a number of ways. So for example, in my work, how I associate them is I have a task, but that task might have a number of steps. Each of those steps I use or represent within a use case. But indeed, those use cases themselves can have their own steps within them as well. So you can have these different layers of abstraction or granularity, if you like. And then this is good to link it to goals. So I will point out that in CAIRIS, there are two things that we need to consider. There are the personas goals, which is potentially slightly different to a systems goals. So personas goals would be to perform some actions or some activities to achieve that task. But it's actually by achieving that task, that's what helps us to achieve goals. Goals, or goal modeling rather, there are a number of approaches that we can use. So there is CHAOS, GRL, ISTAR or TROPOS. CAIRIS uses CHAOS for goal modeling, but it also uses obstacle modeling. Now, obstacles are good for demonstrating where something could obstruct a goal or task from being completed. So if there is an obstruction to a task, for example, this may therefore obstruct a goal from being completed. And actually, because we can decompose goals, it's likely that by not completing that goal or achieving it or maintaining it, there are other goals that we potentially can't now achieve. So actually, from a risk assessment point of view, looking at the bigger picture, certainly in my work, that's what I really focus on or help. Goal modeling really helps in that sense, because now I can see this knock-on effect of risk, certainly from a security point of view. So this is really, really important. Actually, I should have slipped in a slide about risk here, but that's coming in a moment, because once we have gone through this process and once we understand that there are risks that therefore need to be mitigated, there are countermeasures that we can also put into place to hopefully reduce the likelihood of risk. Now, risk is actually captured separately as well in CAIRIS. So as I mentioned, we can associate it with the obstacles, but we do have a whole section where we can capture threats and vulnerabilities, or I should actually rewind a little bit and say that actually now that we have assets, roles, and personas that are related to a particular task, now we can introduce attackers, which are similar to personas, but we can introduce them to consider, well, what assets or what things they might be trying to exploit, certainly the assets that are listed and associated with these tasks. So now we are starting to get a much bigger picture of everything that's going on. CAIRIS, although I haven't actually, bizarrely, added a screenshot here, CAIRIS also features data flow models. So from a threat modeling point of view, this is very useful when we integrate data flow modeling into the process, because now we can actually see, for example, where things are being stored, processed, and transmitted. And this is obviously of real importance to us. So when it comes to assessing risk, I will just say that there is a standardized way, and there are calculations within CAIRIS that will calculate the level of risk for you, which is very, very clever. But we also have something else as well. So in CAIRIS, we are focused very much on usability. Now, when we were constructing the tasks that were being performed by the personas, we can also add further information towards the duration, the frequency, the demand, And where we have goal conflict here, this is actually the persona's goal. So understanding how long it takes a persona to perform this task, how often they might perform it, will give us some useful calculations. So this is aligned with ISO 9241-11 from a usability point of view. But what we can also do, certainly when we've assessed risk, is now reassess the usability score. So when we're trying to reduce risk within a particular system, from a security point of view, we can absolutely be considering the usability of it too. Because certainly if a particular system or a piece of software isn't usable, then this will inherently bring greater risks just from that aspect as well. So we are looking at many things within CAIRIS. CAIRIS can do many things in many different ways. And of course, there is a book about it. We have students at Bournemouth University who use CAIRIS as part of their studies or their projects. So I think students have found this book to be very useful, in addition, of course, to the online information that we have in the manual. So finally now I can stop talking, and hopefully, if all things work well, I can give you a quick demonstration of CAIRIS. I just wanted to give you a little bit of context though, just before I launched into the demo and started clicking things. So just before I do that though, I just want to check the chat. Okay, this all seems to be you talking amongst yourselves. Okay, that's great. Yep, okay. So I just want to say you are welcome to pop questions into the chat. As I mentioned, I am minimizing the chat though because it blocks my screen. But do have some questions in there. We will have hopefully have a short bit of time at the end to talk about questions. But let's do the demo. So this is demo.cairis.org. Now, I must admit, where I mentioned earlier that I use CAIRIS in my VM, I do, but sometimes I cheat a little bit. If I've got something quick to do, just to have a look at, or maybe update a model very quickly, I'll actually come here to the demo. So I'm just going to sign in now as test. Okay, so this is CAIRIS. This is the screen that you will see when you first come to. Now, just for a quick demonstration, I will load a model in a moment, but just as a quick demonstration, the test system does actually have some default or standard examples. So I'm going to click that, and straight away it loads the model file. So this does give some kind of indication of a level of risk. It acts as a bit of a dashboard if that sort of thing excites you. But what we also have here is a whole other list. So this is actually our threat model, and this is actually auto-populated. The good thing with CAIRIS is there are many things that auto-populate for you. So once you add things to the database, it can generate certain models. I will show you some of those models in a moment, but certainly this threat model here is generated from things like when you have threats and vulnerabilities added, maybe then you've got a data flow diagram with some assets that are being used, and if there are threats to those particular assets, it will automatically tell you in the threat model. So I mentioned risks earlier, so I'm actually going to click here. There are a number of concepts. Actually, let me just quickly flick through. So if I click risk, there are a number of concepts there. If I click UX, there are other things here that we can look at as well, and also under requirements. But I want to start with risk because I want to start with assets, because assets really are the central thing within CAIRIS. So when I'm modeling in CAIRIS, it is the assets that I'll start with. I'll start then considering roles and personas that might use these, and then we can start adding tasks. So let me just pick any asset. In fact, I'll click an information asset because that would be more useful. So we just have this simple interface here that starts collecting information. So the asset, the description, the significance, tags. That is tags is an optional field, but there are some that are mandatory. So for example, if I try to create this without a description or a significance, when I click update, it will say, no, you have missed some columns or some fields out. Please go and populate them. Now, as this is an information asset, we can add different properties. So for example, we have accountability added here. but we can have confidentiality, integrity, availability, and so on. We can also decide whether that was of high, medium, or low importance, and we can add a rationale. And once we have a number of other assets within the database, we can also associate these here or elsewhere within CAIRIS. So once we have actually added a whole load of assets together and associated them, we can see these in the models. Again, there are many different models here. So let's start with an asset model. This is an asset model. The colors represent, actually this ties in with the risk elements. So there's a lot of things that in CAIRIS that are colored in a different way. Certainly if it's more orange or more red, this usually means that there is more risk associated with it. Now the asset model, you may recognize some elements of it towards being UML, and that is very true, very similar to some kind of class diagram maybe. So as you can see, we have different associations. Associations can be standard association, they could be inheritance or composition. We also have two stick figures here, Barry and Rick. So they're representative of personas. So where later on, once we've associated a task and some of these assets are being used in a task that's being performed by the persona of Rick or Barry, thankfully CAIRIS automatically links all of these up for you. So this is modeling a typical system. There are different ways to model things, different levels of abstraction or different levels of granularity, and it is quite often dependent upon you, the person using the system, on how you want to use it or model it. So let me just go to have a look at, actually I want to go back up to here and have a look at some tasks. So this is a simple task interface. So again, we're just capturing the information about the task name, the objective, and also where I mentioned earlier that we have environments. I didn't mention that in the assets, but you'll notice that actually we have day and night. So this is two environments. So we might have a description about how something is used in the day, which might be slightly different how it's used at night. Now the participants here, these are the personas that we're associating with the assets, with the tasks, and these personas as well can be linked to roles. So if I just go again for a moment, I'll just go to roles very quickly, and let's click on the Information Security Manager. So there's basic information that we can add here. So there's not a great deal in role, certainly from capturing information. But if I was to go to persona now, just to show you how we can start linking all of this together. So we have this persona of Barry. He's a secondary persona. So there could be primary users or secondary users. We'll capture some of their details about the activities, attitudes, aptitudes, motivations, and skills of the persona. So these are all really, really important. And there down the bottom, we can associate this persona with an instrument technician role. So all fairly straightforward so far. So let me just show you some other models as well. I'll show you a goal model because I will show you another model in a moment which doesn't really have goals. So as you can see, these models can look quite large. In fact, actually, let's just have a look at the other environment to see what is representative of night. So as you can see, at night, the goals are very, very different. Context of use will be very, very different. So even how the assets are associated. Thankfully, though, where we do have these big models, we can zoom in. So you can look at things in much more detail. Actually, just very, very quickly, just in case you're wondering what all these symbols mean. So the parallelograms, so these are these white things pointing, let's say, in the direction to the right. They're representative of chaos goals. For pointing to the left is representative of chaos obstacles. Where we have these red dots here, these are representative of somebody who's responsible for something. So we have an information security manager down here, so that's a role symbol. who's responsible for many different things. And where you see the white and the black blobs as well, this means and or towards the relationships. We can also let's see if this works. We can also filter down as well to a specific set of goals. So we can look at this at different levels. So if you have got a very big model, like I showed you a moment ago, this is very, very useful. Certainly in my work, my models become very, very big, but that's because I'm capturing a lot of information in different environments for a particular context. But in other contexts, it might be a much smaller model. Let me just see, have we got a data flow diagram in here? Yes, this is a very, very standard data flow diagram. So this is really where we can start thinking about threat modeling in the traditional sense. And just to show you very, very quickly as well, let me just go back to the risk aspects. So once we have assets, roles, personas, tasks, and created some attackers, and we would then add threats and vulnerabilities to the database. And then once we have that, we can go to our risks, we can create a new risk, and we can simply select the threat and the vulnerability and provide a name for the risk, and we can add some information here into the use case. And if you can see here, again, CAIRIS on the things on the left is pulling a lot of this stuff through automatically for you, and then it's now calculating a particular risk score. You can't see the calculation here, that is actually hidden behind the scenes, but I'm sure you don't necessarily need to see the calculation, you just want to see the answer. Certainly when something is likelihood is improbable, but the severity could be critical. So just because it might not happen, if it did happen, it could be a bad thing. So perhaps from a risk point of view, we'd still want to have a look at that to some degree. Okay, so that was a very, very quick overview of some of the things that we have in CAIRIS, but actually I want to show you something else now. Because actually if I wanted to save this model, I would just click export and it would export an XML file for me. But on this occasion, I want to import a model. So I'm going to click model, not model package. As you can hopefully see there are a number of different file types that we can choose. Oh, very conveniently, it's already there for me. So I'm hoping this is going to work without any problems. So this model file is actually based on some work which I'm hopefully going to show you very, very quickly in just a moment. So this is based on some current research that we're doing in relation to threat modeling in CAIRIS. So the main focus has been on the data flows, I will admit this. So there is some goals, actually there are, I'll come back to the data flow, there are lots of assets in here as well. So we can see these in the asset model. But I just want to show you these because if any of you can spot some of these assets in here, maybe some of those will be very similar to the proposed NHS COVID app. There's been lots of talk about centralized and decentralized models recently, and so this is certainly something that gave us the idea of using that within the work that we're currently doing. So here, for example, if we want to start threat modeling now with a data flow diagram, we've captured based on the assets that we have, because the assets can be used in a data flow diagram as being external entities, somewhere where we can store things, and indeed the information that can be flowing in between these things. We would use use cases to represent the processes. So the processes are the things in the rounded rectangles here, whereas the external entities are in the square rectangles. So use cases have been used then to be the processes within the data flow diagram. And I'll just show you some of those very, very quickly as well. Actually, nope. There we go, use cases. So this is just very quickly showing you a use case. Very standard interface again across different screens, captures the title, the objective, the basic details, some preconditions, post conditions, And I mentioned earlier that a task could have steps, but indeed a use case can have steps of its own. So we would capture these here as well. So there really is lots of information that CAIRIS captures. There are lots of ways that it can be used. So certainly for threat modeling, as we've seen here, there are things that we can now consider from a risk point of view as well. So we'll just capture a little bit of risk here. We might have also considered some threats. Oh dear, I seem to have broken it already. So we can consider different threats, different vulnerabilities, ultimately to how these assets interact and how information is stored and processed. But of course, the argument for the contact tracing app was a centralized system, therefore storing all of our information on a centralized server was probably not the best way to go. Decentralized model is potentially much more interesting. Okay, so I actually need to stop talking now, because otherwise I will carry on talking for another hour. But I just want to introduce you then to some current research that we've been doing, and this really is current. This is a preprint of a paper which you're welcome to download. So the link is obviously, as you can see here, but it was in the slides. I will share the slides later on. But without further ado, I'm going to stop talking and I'm going to press play on a video so you can listen to Dr. Shamal Faili talking about some of the work that we've done. Okay, here we go.
Hi everyone. This paper on contextualization of DFDs for security analysis is joint work that arose from discussions about metrics for software security at a Dagschul seminar last year on empirical evaluation of secure development processes. Now in this work, we're specifically motivated by metrics and the ability to reason about high-level design models created very early in design processes. And our big idea is that we don't need to trade off the simplicity and expressive power of these models if we can put them in context with other models. So the focus of our paper is the data flow diagram, a simple but expressive modeling notation for modeling the flows between entities, processes, and data stores. It's a well-established system analysis technique and one of the more popular techniques for threat modeling in general. It's an easy notation to pick up, but the limited semantics makes reasoning about them difficult without augmenting them in some way. But doing this weakens the very strength they have as a boundary object between different threat modeling stakeholders. But as the title of our talk suggests, rather than augmenting DFDs, we could leverage the idea that DFD nodes can be put in context by different model elements. And by doing this, we can reason about possible issues in DFDs that would otherwise be invisible. To see why this is the case, let's look at a meta-model of related design concepts. So this class diagram is a subset of the CAIRIS meta-model, which we refer to in the paper. The class diagram shows a conceptual relationship between design concepts and requirements engineering in grey, usability engineering in blue, and security engineering in red. Now we can see that processes are abstractions of use cases, which are a requirements concept. And a use case puts in context a more qualitative task description, which is a usability concept. We don't assume that there is a generic designer who is listing or specifying these model concepts. The models associated with the concepts could be produced by different teams at different times. But because of these conceptual links, we've got a means for reasoning about the impact that usability models might have on security models and vice versa. To see how this works in practice, we've considered how contextualization can help us spot tainted data flows. Now, taint flow analysis is a well-established technique in computer security, and there's also been previous work looking at how this might work for DFDs too, but that requires changes to DFD semantics. Our paper presents an approach where human error sources act as taint sources before and after any data flow processing takes place. Although DFDs are graphs, a DFD is also a set of data flow types, where a data flow object is composed of a label, names and types of nodes where data flows from and to, and although invisible in diagrams, also a set of data items carried by the data flow itself. Based on this definition of data flows, the first step of our approach is to turn the DFD into an array of unique data flow sequences, where the from attribute of the first data flow in the sequence is an entity. This is summarized by the algorithm in this slide, which is described in more detail in the paper. With this array now constructed, we enumerate the data flows in each sequence and log potential pre-process and post-process data flow taint. Now, pre-process taint arises when opportunities for human error and violations are present. And as the conditions in this slide and the paper show, we rely on other models for context. For example, we're relying on tasks that put processes in context, and attackers and personas that put more abstract roles and human entities in context. Now, post-process taint arises when exceptions from processes impact information flowing from these processes. Now, in this check, the process itself provides context for other models, particularly requirements models. For example, system goals are operationalized as processes, where exceptions to these processes obstruct one or more of these goals. In parallel to this, we also rely on the relationship these elements have with assets of value. In other words, assets associated with obstacles that are carried by these outgoing data flows. Our intention is that, provided you've got the necessary models, the approach described should be automated in the form of a suite of model validation checks. Now, to show you this is feasible, we've implemented these checks in CAIRIS, which is an open source software platform for listing, specifying and validating secure and usable system specifications. Because it was developed as an exemplar for the CAIRIS meta model partially seen earlier, it supports all the concepts necessary for our approach. Now, the graphical models you see in the presentation in the paper are automatically generated by CAIRIS based on declarative data processed by Graphis and rendered as SVG. And CAIRIS's model validation checks are implemented as stored procedures within the SQL-based CAIRIS database that stores the elements and relationships of a given CAIRIS model. Now, to implement this approach, we made no changes to any pre-existing visual models or the CAIRIS meta model. Now, to illustrate our approach, we've used it to spot process taint in the specification of a software repository for telemetry software used by a water company, which, although fictitious, is based on a real organization. Now, for those of you who don't know, telemetry software is used to monitor and remotely control clean and wastewater infrastructure, things like pipes that are connected to outstations. Now, as part of the specification, we have a persona which is called Barry, which was created by human factor experts to represent instrument technicians. We've also got a task narrative describing how Barry might modify telemetry outstation. Now, there have been some well-publicized examples of what happens when these outstations are maliciously tampered with. But given the duress instrument technicians making software changes might be under, we'd like to see the impact that this fatigue might have on Barry in this task. Now, how the specification was created is not the subject of this paper. But if you look at the references in the paper, you can get a bit more information about how it was created. Now, but as you can see in the slide, we have made the pilot study CAIRIS model available for those that want to inspect it in more detail. Now, in this slide, we can see the DFD associated with telemetry software modifications, with the bottom left table showing what information is carried in each flow. Now, if we run a model validation check, we're going to instantly complete steps 1 to 3 of our approach, but we're going to break this down to see what's going on, starting with step 1. And we can see from the bottom right table that the results of generating the dataflow sequences is a dataflow sequence array of 5 elements. And to give you a preview of what's to come, we can also see that pre or post process taint flow checks have failed for the first 4 of these elements. Now, the DFD alone doesn't explain why the pre-processed taint flow checks failed, but if we look at the results from step 1, we can see that all the sequences are prefixed with a job data flow, and this contains job information. And that information also happens to be used in the outstation update task that contextualizes the process. Now, we can see the Barry persona interacts with job information, but Barry isn't the only instrument technician here. We can see that this role is also shared by our attacker who, while not malicious, happens to be resource constrained. And that role also corresponds with the entity that's the source of the job data flow. And on inspecting the task, we can see that Barry finds this particularly demanding. Now, the check doesn't tell us what human error might occur, but it does highlight the need for more investigation about what could be tainting the data flow. So it could be that Barry picked up the wrong job info for the right outstation, or maybe the right job info for the wrong outstation. The DFD alone does not explain why the post-process taint flow check fails either, but the use case specification for the process does have an exception we've highlighted in green, and if you look more closely at the obstacle resultant from the exception, we find that it's associated with an information asset, alarm, that also happens to be carried by the alarm data flow outgoing from our process. Now, as to why the exception occurs in the first place remains unclear at this point, but inspecting the broader asset model, seen in the top left of the slide, could be a starting point for investigation. For example, possible problems with the availability of the telemetry network asset could bring us closer to a root cause. Alternatively, we could look again at our outstation update task to spot other reasons for why an alarm might not be sent. In presenting our approach, I hope we've shown that, by putting DFDs in context, we can find potential sources of data flow taint without making any changes to DFD semantics. By indicating otherwise invisible problems, our approach also sheds light on why these problems might exist. Our approach also highlights the potential of leveraging usability models. It's usually the case that such models are empirically grounded and the result of some fairly extensive user research. The resulting user research could yield potential vulnerabilities, so in presenting this work, we want to indicate how human factor experts could play a more active role in threat modeling more generally. One of the nice things about our work is that, should you have interoperable tools that together support the concepts we describe in the paper, you should be able to implement this approach yourself. If you're an interested researcher or developer, I hope the algorithms in the paper and the open source CAIRIS codebase gives you enough cues to get you started. Thanks for taking the time to listen to our talk. I hope you found it useful, and please do get in touch if you have questions or want to find out more about our work.
Okay, well, thank you very much, Shamal. So again, you are welcome to have a look at that video. It's up online on YouTube. Do have a look at the paper here. It's up online as well. Obviously, demo.cairis.org, or indeed, here are the links. I can paste these into the chat in a moment. But as I'm conscious that we are now starting to run out of time, I have now got the chat window open. So if there are any questions, or indeed, I guess, feel free to ask questions through the mic.
I think there is one question from Andre already in the chat. I don't know if you can see that one.
Okay, yeah, I'm just reading it now. Hey, thank you, Andre. Actually, you know, that's a really good question, and I'm not entirely sure I can answer that one, simply because it is a very good question. So at the start of the presentation, you understood that CAIRIS offers a deviation in terms of interpretation from standards. Yes. So regarding the environment, yes, thinking the system, what is your rationale, as I believe it might go against ISO 2382, the IT vocabulary? Yeah, I mean, it's a very good question. So what we have to try to do, and this doesn't entirely answer your question, but what we have tried to do is, where we mentioned usability, for example, or even the risk evaluation, then we have built in certain standards. So this is aligning with obviously industry standards, which is useful worldwide. But where we have been popping different concepts into CAIRIS. So, for example, the data flow diagrams, they didn't used to be in there a few years ago, but we have built in concepts as best as we can, or rather, what I mean as best as we can, that they are aligning with each other, but they again align with different standards as well. So it's a good point, and I would like to try and answer that for you. What I will do in a moment, actually, if I'll just type it here now. Here is my email address. I will put a caveat that my email box seems to be very full these days, so there is a bit of a delay in responding. But in addition to Teams and Slack and so on. But if you do have any other questions, then please do email me. So, for example, Andre, it'd be really cool if you could actually email me, so I can actually then have a conversation with you about this over email, and I might even point you in the direction of Shamal. I should say that Shamal, he really is the daddy of this project in a sense. He is the person that really develops this. There are others as well that contribute, but I really have to give all the credit to Shamal here, because he works so hard. And when you have people like me and many other researchers as well who test this, week after week after week. Part of my testing maybe a couple of years ago was deliberately to try and break CAIRIS, actually, and I might have enjoyed that, but don't tell him that. Oops, this is live, isn't it? He knows now. But no, I did used to enjoy breaking it, because the more I could break it and misuse it in different contexts, the more then that could help us develop it better, make it stronger, make it more robust. So this sort of testing and development, well, actually, this is all ongoing. But I have to say that CAIRIS is pretty stable now and working quite well through this continued testing. So yeah, again, I have to give credit because every time we report an issue through the GitHub, so again, don't forget you can download this on GitHub, but when you report an issue through there, some man magically fixes it for us, and it's absolutely brilliant. So the service has a very good turnaround. Anyway, I noticed that, no, thank you, Andre, thank you for the question. I do appreciate them, and thank you, Alona, as well, for copying that over. However, I noticed that I'm now 1 minute past my time, and I really don't want to take up any more of your time, because I know Stephen needs to come and give another talk as well, which should be really, really interesting. So as I say, please do email me. I'm happy to talk more, just with the caveat there might be a slight delay, but I'm really happy to talk about this more. And obviously, sorry, hang on. Sorry, Andre. Okay, I have to see. Yes.
Okay.
There we go.
All right.
Right, so I'm going to hand it over to back to you now. But thank you very much, everybody. And again, do get in contact if you'd like some more info.
All right. Thank you so much. Thank you, everyone.
Thank you.
All right. So, by the way, we're going to record your YouTube debriefs. That fine for 5 minutes. After this, I'm going. Go ahead.
Super. Thank you. Right. So I think you've probably read the slide by now. We're Areas Risk. We've been building Areas Risk since 2015 and helping our customers to scale out secure design and threat modeling. I think the important message here is how we approach the solution of scaling threat modeling, which is that we want to make it easy for non-security experts, and that it must be integrated with the development process. So we don't just want to be a tool that gets you a report quickly. We want to be a tool that integrates properly with the rest of the development environment, and so that we can play nicely with the dev team. And so the threat modeling isn't a siloed organization or even a siloed activity within development. Right. So let me go on here. We are based on well, I like to think of the way we approach threat modeling in the 4 steps that you know, quite a few people mentioned. Adam Schertijk as well as a proponent of this, and I think the power of these 4 steps is that it's a really simple and understandable way to look at threat modeling. So the first step of what are we building, typically you would answer that by looking at design documentation of what is the system that's being built, using a DFD, using whiteboards, workshops, to essentially get to that answer. What is the description of the thing we're building? And the second step is then what can go wrong. And here, if you're doing a manual approach to threat modeling, this is where you essentially do need somebody with security expertise. You know, it's not enough to just tell engineering teams, just think like an attacker. Doing that requires some skill, which they previously had to acquire somehow, either through some training or through working in security. And the next step is, once you know what can go wrong, you need to know what are we going to do about it. So here the security expert can point to standards of documentation, or potentially the dev and engineering teams could propose countermeasures or controls that they would want to put in place to mitigate the risk here. And finally, you want to know, did this all work out well? So you want to inspect these results, match them up with what is actually going on in the development process, and match them up with what is there in reality. You know, is this plan where we identified what could go wrong and we identified what we are going to do about it, how does that actually measure up to the reality? So the way we've implemented these 4 steps in Areas Risk is that for the first question, what are we building? We use an embedded draw.io instance to draw the diagram, and we use a questionnaire on each component to tease out information about those components. So what are the specific characteristics of each of those components? We use custom questionnaires for each component to do that. Once we have that, the Areas Risk system knows what are we building, and it can then automatically generate threats and countermeasures from a predefined library of risk patterns. So you'll be hearing this term quite often, risk pattern. And risk pattern for us is a group of threats and countermeasures that belong together for some reason. And that reason is something that you would decide. So for example, you could have a risk pattern that's associated with single factor authentication. And you would have a group of threats and a group of countermeasures that belong together because of the fact that you're doing single factor authentication against something. So using this concept of risk patterns, ARIES not only generates the threats, it also automatically generates the countermeasures, so that the system can answer both question 2 and question 3, at least partially for you, using these automated and predefined risk patterns. You'll see here is also plus manual, right? So using automation, we're never going to arrive at 100% complete threat model. And the degree of accuracy of this model is going to depend on the scope of these predefined patterns and how well these patterns match to the system that you're building. But I'll go into a bit more detail a bit later on that. And then the fourth one is actually quite interesting. Now, did we do a good job? Well, we can automate that to a large degree. If we can integrate with systems like Jira, Azure DevOps, Rally, essentially the work management tools for development, and if we could push controls and countermeasures to Jira, we would know what the state of those countermeasures are. So ARIES, using a two-way sync, it can find out what is the state of this countermeasure that we had proposed in item 3. So in this way, we move away from this document-based approach where, here's your model, here's a document, now go and build that, to a more dynamic approach where we can automatically sync the status and we'll know what has been updated and what not. So let me stop this sharing here and start a new share over here. So this chart, I think, explains the approach we've taken with ARIES quite well. If the blue line represents the accuracy of our threat model, and on the y-axis we're measuring accuracy, the more accurate my model, the more it represents reality. And on the x-axis, we've got the resources required to get to that accuracy. So, and I think this is anecdotal and maybe gut feeling evidence, and also from actually doing threat models, that this is not a straight line, right? You can identify a lot of threats and countermeasures very easily at the start of any, even a manual threat modeling exercise. And then it starts becoming more difficult, right? As you're looking into more of the details of the system, as you're investing more time in doing so, you're going to get better results, but it's costing you more to do so. So our objective with ARIES is to automate the easy stuff and at least make the hard stuff possible to do from a manual perspective. And as you can build out the ARIES risk knowledge base and add more patterns and add more content to it, you can start shifting this line so that ARIES can do more and more of the hard stuff as its knowledge base increases. But ultimately, what we want to do is we want to arrive at a threat model very quickly, very easily, where a non-security expert can do it and they still have a usable piece of output on their side. So I think the best way to see this is just to see it in action, and I'll show you what ARIES risk looks like over here. We have a menu on the left-hand side. This shows us, dashboard, some administration section. Given the audience on this call, I also want to kind of dive into the how, right? How are we doing this? So I'll show you some of the guts of the system. But first, I want to show you what does it look like to the end user. So the person who is doing the threat model, what do they see from ARIES risk? Okay, so starting off with new product. A product is essentially a thing we want to model. I'll start with new product here, and let's call this a example web let's call it the web app. And I can enter some metadata for this application. And actually, in a default installation of Aries, you'll only see up into description. The additional fields here, business line, criticality, number of users, these are custom fields that I've added to this instance. And that's something that can be useful to you where you want to maybe capture some additional metadata that's going to inform the threat model. So here I've just created some example values. You'll also see that criticality is not editable. It's a field here that's non-editable by me as the user, because the admin of the system can create rules that will operate on these fields. So some rules will read some of the values and they can write to other values in the system. So I'm going to just click on create here, and we're going to get into the draw.io diagramming system. And this is 100% draw.io. It's also 100% embedded into Aries Risk. So there is no data being transferred to draw.io servers. This is all embedded here within this Aries Risk instance. So to start off with, I'm going to need to choose some trust zones. Let's say I choose a zone here, and I choose a public cloud zone here. And we've got predefined components that make our life easier. So I can say we've got an S3 bucket, which will already have some threats and countermeasures associated with just the fact that it's an S3 bucket. And if I go over to Internet and drop a web UI, I've got two components in my model. And in fact, at any point, I can click on generate, update the model, and it will Aries will generate the model based on what it knows. So currently what it knows is that there's a web UI on the internet, there's an S3 bucket in the public cloud, and that's it. But even so, there are some inherent threats that are to those two components. So if I did go and generate it, and I would, for my S3 bucket, I have a threat, and we have recommended countermeasures to that threat. I have another sensitive data compromised by unauthorized access, and we have to that threat as well. And for web UI, we're going to have some threats included here that are inherent to the fact of using a web UI. So we've got cross-site scripting attacks, as a threat here, and countermeasures already listed over here. Okay, but ultimately, I'm going to want to provide a bit more detail than just what the components are. I'm also going to want to provide a data flow, and I use this using the normal way that Draw.io does this, where you can drag these arrows to create data flows. And I could also, by right-clicking on the flow, I can provide some metadata. So I could say this is backup data. I can tag it with any number of string tags, so I can invent my own tags. I don't have to use the pre-populated list of tags. So I can add some tags here, and I can also indicate what type of data is being transmitted. Customer data, and I'll click Save. So we've got a single data flow from the web UI to the S3 bucket, and by right-clicking on the component, I can now also provide more details about that specific component. So what I'm going to see here is a web UI. You'll also notice that at the bottom here in this analysis panel, it's telling me that a security policy has been applied. The ASVS level 1 is going to be applied to this component. Now, I know this is true because I created a custom rule that says for all internet-facing components, apply the ASVS standard. If I change the trust zone, if I put it somewhere else, that rule will no longer be true and it won't execute and I won't get the ASVS. If I put it back in the internet, that rule does execute and I do get the ASVS as a standard on this component. And just a note on this concept of applying a standard, when IRIS applies a standard, it does not include the entire standard. It only flips existing countermeasures that are already in the model that belong to the ASVS from a recommended state to a required state. So the purpose of this is not to replace a 200-point checklist just by putting an automation system in front of it. What we want to do is we want to reduce that 200-point checklist. So IRIS is using the answers that I'm going to provide in this questionnaire to determine which parts of the ASVS are relevant to this web UI. Okay, and as I go and answer some of the questions here, if I say we are processing PII, these are predefined data types, data assets, and you as the admin user can go and edit, delete, and add your own data assets to the system. So these are kind of out-of-the-box assets. Some of them have rules attached to them. So you'll notice here that the next tab is authentication, but if I choose PII data is processed, then a new tab appears around data privacy, and it's going to ask me some details about data privacy. Is this EU citizen data? I'll say yes, and then it's going to ask two mandatory questions. Does this data leave the EU? It does not. And does this component itself expose an interface that the user can interact with? In other words, is this web UI interacting with the end user? And in this case, yes, because it's a web UI. And the reason for these questions is similar to what we're doing with the ASVS. We're going to apply the GDPR as a standard, but at the same time, we don't want the whole GDPR. We only want the parts that are relevant to this web UI and to what the user intends to build with this web UI. So by answering these two questions, we know that there are some parts of the GDPR that are relevant and some parts that are not relevant. If it's not relevant, it doesn't appear in the threat model. And the rest of the questions follow a similar kind of principle, right? As we answer more questions about what we're doing on the web UI, IRIS knows which risk patterns apply and which to import into the model. I don't have to answer these, so at any point I can say, I don't know yet. I don't know what framework we're using. That's too early on. Just generate the model based on the information I have provided. I'll click on done. Let's update. And IRIS will now import new threats and countermeasures into the model. So on the threats view, I will now have underneath my web UI component, I've got some threats like this one. I can see the threat. I can see we have no plan to mitigate this. It's an unmitigated threat. We have no countermeasures planned, and we've made no progress in implementing them, and the risk rating has been associated with it. We've also not run any tests against this. And looking at the bottom half of the screen, I can see what is the technical weakness or weaknesses that will allow this threat to manifest, and what are the countermeasures to that weakness. Here, the countermeasure is in the recommended state, and this is usually what you will see when a model is generated from IRIS Risk out of the box. All the countermeasures are going to be recommended, and it's up to me as the user to decide I want to apply that countermeasure and turn it into a requirement. So this essentially means I, the human, accept you, the tool's recommendation, and this is a good idea, and we do want to apply it, and I turn it into a required countermeasure. So this also indicates to IRIS that we have a planned mitigation in place, and we intend to do something here. Just going to the one above, this is on the S3 bucket. I've got a threat here. I've got a number of countermeasures, but I could say, well, this threat is actually not applicable, and I need to provide a reason, good reason why it's not applicable, but it will be hidden from the view. It's still stored in our audit trail, so we know that that threat was marked as not applicable by a particular user at a particular time. And it's a similar kind of concept if I want to accept the risk. I can also accept the risk. So this is relevant, but we're just not going to do anything about it. And I can give my reason over here. And so I can move through the rest of the threat model, and you'll notice that some of these threats, and these are all related to personal data, are already marked as required. And I, as the human, didn't go and make those decisions. And that's because of the policy that said we are going to apply the GDPR as a standard onto this model. It automatically flips them from recommended to required. And if I double click on this countermeasure, I can get into more details. This is what it describes should be done. And it's linked to these two articles in the GDPR. And here's a reference link to the GDPR. In addition, here is how I can verify at a very high level that this is so. Okay. So if I put myself into the mindset of an engineering team, they're new to threat modeling. They don't necessarily have a good handle on how to do this manually. By using AIRIS, by drawing a diagram, by answering questions on the questionnaire, and having the security team already define policies that mark some countermeasures as required, it means that I need to do very little work for me to arrive at a list of countermeasures. And my list of countermeasures that are marked as required are the things or the minimum that I need to do to satisfy my security team. So leaving aside for the moment the additional manual threats that we could go and find with the system, if we go just with the 100% automation approach, looking at my countermeasures, I've already got a number that have been marked as required. And as a member of the engineering team, I don't want to work in this AIRIS risk system. And in fact, if I'm only one person in a team, I don't want 12 of my colleagues to also come and log into this system to find out what their requirements are. So we have the facility to create new issues on Jira or TFS or Redmine, so that every one of these countermeasures becomes a ticket on the ticketing system. So for example, we had one here, create a consent mechanism. It was marked as required. It now exists here on Jira. And I have a description, which is that same countermeasure description. It describes what should be done. It links to the GDPR, some reference material, and also gives me high-level testing steps to verify that this has been done. You can also configure the project to tag or to label the tickets with particular labels, just so that the engineering team can filter this out if they want to filter it out. They're sometimes not going to be happy when they all of a sudden got 40 new tickets on their backlog. It's going to be useful for them to say, okay, we know this comes from AIRIS risk, or it's a security ticket. I'm going to do 2 of those for every sprint, and they'll pick the top 2 highest priority tickets to work on. So this is quite useful for the, to communicate the list of work that needs to be done with the rest of the engineering team, which means, only 1 or 2 members need to be involved in the threat modeling process. Once they've defined the tasks, the requirements, those are pushed up to Jira, and the rest of the team just works off of Jira. They don't even have to log into AIRIS. And as they do work on these tickets, they would work on them as they normally would, mark them as done if they're done. And let's do one more. Here's another ticket to apply authorization checks. And once I've done that, I'd also mark it as done. And let's take one more. This is to implement sensitive validation logic. And the countermeasures are quite detailed. So because these are predefined threats and countermeasures, and because we know, or AIRIS knows when they apply in the model, they can be quite specific. So rather than being very generic of saying encrypt data, we can now say data is at rest, encrypt it using these ciphers and using this technology because we know you're encrypting it on S3, and S3 only offers these particular mechanisms of doing it. Right, so as the engineering team, I'd mark these tickets as done if they're done. And CAIRIS will now do a two-way sync. So every 5 minutes, it goes and consults Jira, and it asks, what is the latest state of these tickets? They're all currently marked as required in CAIRIS. And if I can force that now so we don't wait around 5 minutes and update, we should now see an update in the status of these countermeasures. So this is implemented, and these two are implemented. So this is step 4 of the threat modeling steps, right? How are we, did we do a good job, right? Are we actually doing the things that we have planned? And I can see it here on the countermeasures view. I can also see it here on the threats view. So I can see, for example, over here, we have already mitigated 50% of the risk. We intend to do nothing for the remaining 50%. And the current risk rating or residual risk rating would have been reduced by a proportional amount. So this would have been a high or a critical, and it's been reduced to a medium because we've done something here. And looking at the bottom half of the screen, I can see why it has arrived at this conclusion. It's because there are 2 countermeasures. This one is marked as implemented. This one is marked as recommended, meaning no one's going to do that until it's a requirement. It's just a wish. So if we did want to implement it, somebody needed to go and mark that as required. For some of the other threats here, I'm going to see we have mitigated all of the risk. Our countermeasures are complete, and the current risk rating has been reduced to very low because there was only one countermeasure and it has already been implemented. Okay. So this is going from a perspective of an engineering team trying to do as little as possible to arrive at some baseline, and so they can start doing work on that baseline. But of course, the really interesting threats are going to be found by the human, by somebody thinking about the problem. They're going to be thinking about this particular design, and what is this customer data going from here to here? How are we handling it? And what are we doing around that? So in that case, you can, of course, edit everything that is in this auto-generated diagram. The fact that the system pre-populates with some threats and countermeasures is just a way to get you started quickly. It doesn't mean that this is the final result. So you can say, in fact, in our web UI, there's a new use case. There's a new function we have. We're going to call it funds transfer that happens in our web UI. So I've got a new use case called funds transfer. And within funds transfer, I've got a new threat that I want to add called and so I can add my own custom threat, a new threat. We do flag manually created threats as manually created. They don't differ any other way except for this flag. And the purpose of this flag is so that if somebody else comes in afterwards and wants to review this model, they can very quickly see what is manual, what has changed from the predefined library and patterns that have been defined in areas. So right now I've got a threat. I've got no weaknesses and countermeasures related to it. And here I can, if I wanted to, describe a weakness like that, or a number of weaknesses that could be technically exploited. Or if I'm not really interested in that level of detail, I could just go directly to defining a new countermeasure. And the same way as I did for threat, I can just type in a completely new countermeasure, or I could search through the previous threats or previous countermeasures that we've used in other projects, and also countermeasures that exist in libraries. So if I search through countermeasures and I look for the word encrypt, it's going to be lots of products, templates, or libraries that have the word encrypt in them. So I can narrow this down and say I only want to search in libraries, and furthermore, I want to search in the IoT library. Okay, so now I've only got a few countermeasures, and let's say for argument's sake, this is the countermeasure I want to apply. So CAIRIS will now copy it over from this library and put it into the model as a requirement. It's not on Jira yet. I can either do it from the countermeasures tab in batch and say everything that's a requirement, make sure I've got a ticket, or I can do it individually here and say go and create a new issue, and we now have a new ticket that represents that countermeasure on Jira. Okay. And in a similar way, anything that is auto-generated can be edited, right? So I could say, you know, this let's look at, yeah, this thread over here. It has this countermeasure. I don't agree with this. You know, this is wrong. I want to remove it from this thread, and I want to go and add a new one. Oops. Oh, sorry, I created a new ticket instead. I want to add a new countermeasure, and I can create a new countermeasure that's attached to this. I can also edit all of the fields of this countermeasure. So I can link it to standards. I can change the mitigation percentage, and I can also define how you would test it. Okay, so everything in the model is editable. You can change it. If you do make those kinds of changes, they are stored in our audit log. And for every threat and for every countermeasure, we have a well, field by field tracking of every change that has been made to a particular threat or a particular countermeasure. So I can see here that at this point, this date and time, this user mitigated this threat. And we've got full traceability, particularly if you're in a regulated industry and you need to show this to the regulators that you had a plan, but also that this plan has been implemented, or at least that the development team is working on this plan. Okay, I think this is probably a good point to break for questions. Any questions at this stage?
Looks like no questions so far.
Okay. Okay, so I'll continue. There are two areas I want to show you as well. So the first is, how do we get more detail on that question number 4? Did we do a good job? Currently, CAIRIS is using the Jira ticket status as the source of truth. So we've said this consent mechanism has been implemented because this ticket on Jira has been marked as done. Therefore, we have mitigated all of the risk, and therefore our current risk or residual risk is very low. But we can also go and test this. So, you know, this may not be true. A developer might believe that they've implemented, but there's an error in the implementation, or this countermeasure doesn't completely mitigate this weakness, and there's an error in our model. So we can do two types of tests. We can either go and verify the presence of this countermeasure, or we can verify the presence of a weakness. In other words, if we found a vulnerability. And this really depends on what is the type of testing that happens further down the pipeline. What happens after your threat model? What is the type of testing that comes in after the fact? So if we are doing something like a pen test, it's more likely they're going to find presence of weaknesses, right? They're going to do negative testing. If I double click on that weakness, this describes the weakness here. And on the test, we can record test results. So I can say this test has failed. And I can also add some notes. I found a bug because when I do X, Y, Z, and I can describe as the tester what I found here. I've done this manually. you can also upload this result via the API. So you can call an API endpoint and say, I've got a test result for this weakness, and this is the result. So I'll click on save, and we can save that result. And IRIS will now update its model. It will say, here is a confirmed vulnerability which contradicts the countermeasure status. Therefore, we believe the test more than we believe the countermeasure status, and we mark this risk response as unmitigated. The countermeasures are complete. That is true. They are implemented, but those are either the wrong countermeasures or they're not implemented properly. And therefore, we will increase the current risk or residual risk back to its original value. So it goes back to a high. Because we can't trust this implementation status as the source of truth at the moment. We can now communicate this to the engineering team. So we can create a new ticket for this. I can do it with one click. It can also be done automatically if you configure the project like that. Create new issue for weakness tests that have failed. And if I go over to Jira, we've got the description of the weakness. It's also been tagged. And whatever the tester wrote has been included over here. And we would include that same information in the comment. So it's a manual test, it failed. And here is the tester's notes. It's also linked to the countermeasure that should have mitigated this. So this is the countermeasure that was marked as done. And now as the engineering team, I have the information that I need. I know what the problem is. My tester hopefully wrote a good description of what they found. I have the context. I know this is the thing that should have mitigated it. And if there is some additional details, or in fact, if this has reappeared, if this happened over and over again, I would see in the comments that this is maybe the 5th time it has failed, but 3 times previous to that, the test had passed. So that's why we write into the comment section in Jira, so that we have this rolling history of what happened with this test over its lifetime. And IRIS will automatically add to the comments, and it will also automatically open or close this ticket based on the testing status that's coming into IRIS. Okay, so in this, from what you've seen so far in terms of generating the model, getting tickets onto Jira, and then syncing with Jira, optionally also doing testing and getting that testing information onto Jira. The way we see IRIS is that it's almost an orchestration tool for security work. So it allows the security role, it doesn't need to be a security expert, but somebody who takes on that role to draw the diagram, get their threat model, decide on the requirements with assistance from the automation component, get those onto Jira. And then if something changes during that lifetime, if countermeasures are being marked as done, we're seeing that reflected in IRIS. If a new vulnerability comes out, that change is also being reflected in IRIS and being pushed to Jira. So we're always using Jira or Azure DevOps, or whichever system that you're using, we're always using that as the communication mechanism, so that engineering teams can work in real time. And they have work in front of them, and they don't have Excels and PDFs and docs to work from. Okay. Right. So one of the other areas I wanted to show as well, which is kind of the power of IRIS, is really in the definition of these predefined components and in the risk patterns. So as the admin user, I can come in and look at the templates, the libraries, and the rules of the system. All of the content in IRIS, which means all of those predefined threats and countermeasures, all of the rules that determine when do I get to see a particular threat or a countermeasure, and also when do I see a particular question in the questionnaire, all of that is part of the knowledge base, which is collected in the rules and in the libraries. And all of that is editable, exportable, and importable. So we don't have any content that's kind of locked away inside of IRIS. Everything can be imported and exported from the system. If I wanted to create a new library and a new rule, we can very easily do that within the system. Let's quickly put a goal for ourselves in place here. Let's say OWASP web app demo. We've got this case, and let's say I want to create a rule that says if there's a data flow from the internet into a trusted partner and it contains the tag backup, then I want a particular threat and countermeasure in my model. Right? So you can create that rule and you can create those threats and countermeasures within areas. Let's first go and create the threat and countermeasure. To do that, I need to put it into a library. So I can add it to the existing libraries, or since there's no limit on the libraries, I can just add new libraries. Let's call this Trusted Partner Data Flows. A library can contain risk patterns. This one currently has nothing. It's just been created. So let's go and create a new pattern. Let's call it backup data going to partner. Use case is data transfer. And the name is, my special data transfer threat. I've created a single threat attached to this risk pattern, and I need to attach at least a countermeasure. So I can add my countermeasure here, and I've got a very basic risk pattern, single threat, single countermeasure. And now I can go and create a rule that's going to cause this to appear in my model. And in fact, all my models, all of the rules are global. So depending on the conditions you put on them, they will be applicable to a model or not, but all of the rules execute for all of the models. So firstly, I can choose the logical place to put it. I'm going to put it in the same library. This Trusted Partner Data Flows library has no rules at the moment. And we create a new one. So the condition for this rule, firstly, this rule is not a component rule, it's a data flow rule. The condition is that the destination trust zone is trusted partner. Another condition is that the origin trust zone must be internet. And another condition is that the data flow contains the tag backup. Okay. And if all three of these conditions are met, then I want to take the action of importing a risk pattern into either the destination component or into the origin component. So the threats and countermeasures are linked to the data flow, but ultimately they must belong to a component. And because the JIRA ticketing or the ticketing systems are configured per component, you'd really choose this depending on who needs to do the work, right? If this countermeasure is going to be implemented by the destination, then the threat should go to the destination because it's that team that needs to do the work to mitigate it. So I'll choose destination. The library here that we're going to choose is the library that we've just created, Trusted Partner Data Flows, and it only has one pattern in it. So that's the one we're going to use. And click Save. Right, so our rule is now active within the system. If I wanted to retroactively apply it to all of the models that I have, I can use this button. And if these conditions are met, it will import this pattern into the destination. Since I don't think any of these are actually true now, I can also do it in real time, and this is going to affect my model in real time. So go over to my architecture and say I've got a new data flow from internet. Oh, I need to first put something in the trusted compartment, trusted partner. It doesn't matter what it is. That's not the condition. The condition is just that it's going to the zone. So it's going to that zone. And if I edit the metadata, the tag needs to be backup. And that was it. Save. Execute. And if I look at my threats, these should be attached to the destination, so to the Java applet. If I go to my Java applet, I have a new use case called data transfer. It's linked to a data flow, and the threat is my special data transfer threat, and the countermeasure is do something to mitigate this. All right. So this will now appear in any component where those three conditions are true. So the rule system is actually a very powerful way for you to define when do you see certain threats and certain countermeasures in the threat model. It's quite powerful, but it can also become complex to deal with. You know, this is one rule. Imagine if you had hundreds of rules. So there's an easier way to get static threats and countermeasures or static risk patterns associated with components, and that's by using component definitions. So imagine that this very same pattern, which consists of the use case data transfer, my special threat, and do something to mitigate this. Imagine that this pattern applied to a specific component, but always that component. So in that case, I could go to my component definitions, and I could create a new definition. Let's call this the OWASP magic component. I can describe it. I can also put it into a category. Let's put it into the OWASP category. And now I can define which risk patterns should be associated with it statically, regardless of the data flows, regardless of what I answer on the questionnaire for this component. Just the fact that this component exists, it must get some threats and countermeasures. So I'll choose the library, and I've now attached this particular pattern to the component. I can also attach multiple. So I can go and say, well, actually, I know that this OWASP magic component also has some similarities to Azure SQL. So I'm going to use that pattern as well. And I'm going to get a combination of these two patterns on my new component. I'll click Save. And now going over to my OWASP example app, I can say go and add a new component. On the left-hand side here, I'm going to see a new category, areas OWASP, and a new component. Drop that on here. No data flows, no additional details attached to it. Generate model. And if I go and look at the threads attached to this OWASP magic component, it's going to have some related to Azure, and one of them is our particular risk pattern that we chose to import here. Okay, so I've touched on a bit on the rules and the libraries. The rules can be, I think, I could talk for the next half hour on the rules. One of the things I wanted to mention is that we use the JBoss D rules engine as the actual rules engine, which means that every rule that you create using that graphical editor is ultimately translated into a Java D rules rule. And if you wanted to, if this editor doesn't give you the flexibility you need, you can drop down into this level of detail and this level of customization over the system so that you can define exactly the set of conditions that you want to see when you generate your model. Okay, any questions? No.
Nope, it seems we're all stunned into silence by your demo.
Don't know if that's good or bad.
I'm sure it's a good sign.
Good. Excellent. So, well, I think one important thing to mention is that we do have so Wierckx is a commercial product. We do have a community edition, which is free to use and to sign up on. There are some limitations, so you're not going to get access to all of the libraries. The ASVS library is in there. The mobile ASVS library is in there. And right now we're on version 2 of of community, which means we don't yet have the draw.io integration that I've just shown you. We've got a simpler diagramming system, but we are going to upgrade community to using draw.io within the next few weeks. And we will email everybody on the community edition as soon as we make that update, so you have the full power of draw.io in the community edition. Okay. Great. Well, I really appreciate everybody's time and for attending this this presentation, and thank you to Stephen and OWASP for organizing it.
All right. So, any other presenter? All right. So, that. Hello, Stephen.
Yes, I think we have 6 more minutes in case there are some questions.
Yes. Any questions? And then after that, we're going to make a debrief. Okay.
Okay.
All right. Okay. So, any questions from our attendees?
I think not. So, okay.
That's it. All right. So, thanks everyone, and see you again this afternoon for this threat modeling tool again, the afternoon session. All right. Thank you.